Usually, water is considered as the most undesirable element. Conventional architecture is more about creating those protective layers that are sealing the building against water. But through this sealing approach, basically, buildings do not breathe anymore. In water-driven membranes, I investigate methods of designing building envelopes and mostly facades of buildings with water in order to increase bioreceptivity, but also promote local biodiversity. I'm largely inspired by sea sponges like this one, which is from Kalymnos Island in Greece. I study their porosity and their filter feeding mechanism, which means that the sponge sucks water and this water carries nutrients and other organisms that attach inside the sponge and colonize it. So I take the principles from the sponge and I apply it to clay. First in the shape of tiles and then proceeding to larger volumes and scales. I poke holes on the clay, inspired by the porosity of the sponges, in order to create conditions for biological growth. There are many plant species and microbial species that can filter the water. But also, algae can produce very efficiently oxygen, for instance, and they absorb carbon dioxide. It has to do with the management of water resources in urban areas in order to enhance climate resilience for cities. It can provide cooling and the regulation of humidity, which is important, especially in the face of extreme weather phenomena such as storms or extreme rainfalls and droughts and water scarcity. I imagine the buildings of the future to, yes, on one hand be more green and have cavities and crevices that are weathered and colonized by growth. What could change is how humans inhabit their homes and allowing for coming in contact with other species and learning about other species and their properties.